ton times on energy. The whirling blades of these wind turbines focus stark against the darkening sky at the sunset. Energy of the wind causes the blades to spin, and the energy of the spinning blades is used to generate electricity. People have been using wind for energy for centuries. Until about 200 years ago. For example, ships depend on wind to sail the oceans, and windmills have long been used to gather wind energy to pump water, do other useful work. Today, wind energy is making a comeback. Do you know why? One might be advantage of using the wind for energy. They would rather babysit younger children. If you did it, then you'll probably notice that the young children are often very active, seem to be constant in motion. It may be hard to keep up with their boundless energy. What is energy and where does it come from? Energy's ability to cause change in matter. Energy can be also defined as the ability to work. Work is done whenever a force is used to move matter. When work is done, energy is transferred to one object to another. For example, when the batter uses energy to swing the bat, it transfer energy to the bat. Moving bat, in turn, transfer energy to the ball. Like work, energy is measured in joule or Newton times meters. Energy exists in different forms. Some forms of energy are mechanical, electrical, and chemical energy. Most forms of energy can also be classified as kinetic, potential energy. Mechanical energy is the energy of objects that are moving or have the potential to move. What is kinetic energy of these things are moving? Kinetic energy is the energy of moving matter. Since that it's moving, has kinetic energy from the atom in the matter to the planet's solar system. Since what kinetic energy can do work. For example, the hammer can do the work of pounding the nail into the board. The amount of kinetic energy in a moving object depends on its mass and velocity. Object with greater mass or greater velocity has more kinetic energy. Kinetic energy moving object can be calculated with the equation kinetic energy equals mass times velocity squared divided by 2. This equation for kinetic energy shows that velocity affects kinetic energy more than mass does. For example, if mass doubles, kinetic energy also doubles, but if the velocity doubles, kinetic energy increases by a factor of 4. That's because velocity is squared in the equation. Or the potential energy in many parts of the world, trees lose their leaves in autumn. The leaves turn color and then fall from the trees to the ground as leaves are falling. Have a kinetic energy when they're still attached to the tree. And they also have energy, but not because of motion. Instead, they have stored energy called potential energy. An object has potential energy because of its position or shape. For example, leaves on a tree have a potential energy because they could fall due to the pull of gravity, which is gravitational potential energy. Before leaves fall from trees in autumn, they have potential energy. Why do they have the potential to fall? Potential energy due to the position of an object above Earth is called gravitational potential energy. Like the leaves on trees, anything that is above Earth's surface has great potential to fall because of gravity. Gravitational potential energy depends on object's weight, and its height above the ground can be calculated with the equation. Gravitational potential energy equals weight times height. Child weighs 70 newtons and is 5 meters above Earth's surface, and his potential energy is gravitational potential energy equals 70 newton times 5 meters equals 350 newton times m, or 350 joules. What is elastic potential energy? Potential energy to an object's shape is called elastic potential energy. This energy results when elastic object is stretched or compressed. Elasticity gives them potential to return to their original shape. For example, the rubber band has been stretched, but it will spring back to its original shape when released. Spring like a hand spring. The figure has elastic potential energy. When they are compressed, what will happen when the hand spring is released? What is energy conversion? What happens when a child jumps off a small table? Its gravitational potential energy changes to kinetic energy as we fall toward the ground. However, he can his potential energy by getting up from the ground and climbing back to the table. It requires input of kinetic energy. Since changing energy are examples of energy conservation, process which energy changes from one time to another. What is law of conservation of energy? Law of conservation of energy applies to energy conservations. Energy is is not used up when it changes form, although some energy may be used to overcome friction. This energy is usually given off as heat. For example, Child's kinetic energy at the bottom of his falls the same as his potential energy is on the table, except for a small amount of heat resulting from friction with the air as he falls, an example of energy conservation, and many other examples of energy conservation between potential and kinetic energy. On a swing, gravity gives the swing a greater potential energy when the swing is highest above the ground, and the least potential energy where the swing is closest to the ground. Where does the swinger have kinetic energy? When the swinger is moving on a trampoline, gravity gives the jumper potential energy at the top of each jump. Elasticity of the trampoline gives the jumper potential energy at the bottom of each jump. Where does the jumper have kinetic energy? When the jumper is jumping, energy continuously changes back and forth between a potential and kinetic energy on a swing trampoline. Make a summary. Energy's ability to do work. Work is done. Energy is transferred to one object to another. Energy can exist in different forms, such as electrical and chemical energy. Both forms of energy can also be classified as kinetic or potential energy. Kinetic energy is the energy of moving matter. Things with kinetic energy can do work. Kinetic energy depends on object's mass and velocity. Potential energy is the energy surrounding an object because of its positional shape. It includes gravitational potential energy and lasting potential energy. Gravitational potential energy depends on object weight and height above the ground. Energy conservation occurs. Energy changes from one type or form of energy to another. Energy often changes between potential and kinetic energy, and is always conserved during energy conservations. That's it. Thank you very much. One-time deep major scale, category number 1, and pulse dance.